Okay, think about this for a second. What if that steady, relentless march forward you perceive as time um, isn't actually a fundamental part of the universe at all?
Right.
What if physicists, the very people who measure the cosmos, struggle so deeply with defining it because maybe, just maybe, we've been looking at it the wrong way?
Mm-hmm.
Welcome to the deep dive. Today, we are plunging into a truly fascinating and, frankly, pretty audacious idea. Constructor theory, proposed by David Deutsch and Marletto.
That's right.
This deep dive into their, well, groundbreaking work offers a fresh.
Yeah, and grappling with these fundamental challenges and the new theories attempting to overcome them isn't just an exercise for theoretical physicists hunched over
Oh,
equations.
no.
It's crucial for seeing the universe and really our place within it in a completely different light. This deep dive is kind of your shortcut to a sophisticated understanding of a very complex, very foundational topic.
Okay, let's unpack this then. Let's start with why time has become such a persistent headache, really, for physicists in the first place. What's the core problem?
Well, the problems are indeed profound, and they crop up across physics. In general relativity, for instance, time isn't treated as this unique, independent thing at all.
Right?
It's treated as merely another coordinate, much like, length with height. And this leads to the rather perplexing concept of infinitely many times.
Infinitely many. Wow.
There's no single universal clock ticking away for everyone and everything. It depends on your frame of reference, your gravity well. And then when you move into the realm of quantum physics, the issue actually kind of worsens.
It's worse, how?
Yeah. Here you're confronted with this baffling idea of multiple coexisting times and, frankly, the meaning, the interpretation of these. It remains largely unknown. It's a fundamental mystery right at the heart of our most successful theories.
Multiple times existing at once.
Mm.
That's hard to wrap your head around.
It absolutely is. So, given these inconsistencies, what's the standard workaround? What do physicists usually do?
Yeah, how do they cope day to day?
Well, they essentially bootstrap time from matter itself. They measure relative changes. Think of the regular oscillations in an atomic clock, for example.
Like counting picks.
Exactly. We observe change, predictable change, and from that change, we infer time. It's a pragmatic solution. It works for experiments, but it doesn't resolve the underlying conceptual disconnect. It kind of kicks the can down the road.
So it sounds like our most powerful traditional approaches, general relativity, quantum mechanics, while incredibly successful in so many areas, they fundamentally struggle with the very essence of time itself.
That's a good way to put it.
It's almost as if we can measure the river's flow incredibly accurately, but we can't quite grasp what the river is. This clearly signals the need for a truly paradigm-shifting approach, doesn't it?
It really does. The foundations seem shaky when it comes to time.
So given these deep-seated problems with how we've traditionally viewed time, what truly groundbreaking approaches are physicists exploring? This brings us, I think, right to Deutsch Marletto's constructor theory.
Exactly.
You called it radical, and it seems like it doesn't even try to build on general relativity or quantum mechanics. It just starts fresh.
Precisely. It starts from entirely new first principles. The core tenets are revolutionary. Instead of defining the universe by particles or fields or forces.
Usual suspect.
Right. Constructor theory posits that the universe is defined by possible transformations, what they call tasks. The focus shifts entirely from what is to what can be done, the potential for change.
Okay, tasks.
Yeah.
Like building a molecule or computing something.
Exactly. Any physical process, any change is a task. And these tasks, these possible changes, are made possible by constructors. Now think of a constructor as a system that's capable of facilitating changes. Okay. A great analogy they use is a catalyst in chemistry. It enables a reaction to happen, speeds it up perhaps, but it isn't consumed itself, it just makes the task possible.
So the constructor is the enabler of the task.
You got it. So in this framework, the universe's fundamental properties aren't determined by, say, the Big Bang's initial conditions or its fundamental particles,
Right.
but by the kinds of constructors it allows, what kinds of transformations are possible in our universe, what mechanisms make those possibilities real. It's a universe defined by potential and enablement.
That's profoundly different. So if the universe is defined by what can be done rather than what is, does this framework then predict different outcomes for experiments we already know? Or is it primarily a new way of interpreting reality?
Well, it's aiming for both eventually. It's definitely a new interpretation, a new language for physics. But the hope is it will lead to new predictions, particularly where current theories conflict or break down.
Gotcha.
But getting back to time, if time isn't fundamental in this theory, how on earth do they manage to construct it from these tasks and constructors? Where does time come from?
Yeah, that's the real magic trick, isn't it? How do you derive something so basic, so seemingly fundamental as time from this entirely new language of tasks and possibilities?
Well, you might initially think, okay, a clock ticking, that's just a recurring task, right? Something happening over and over. So maybe those recurring tasks could define time.
Makes sense intuitively.
But they explain why these recurring tasks aren't reliable enough on a fundamental level. Why? Because, for example, the rate of recurrence might change. Think about processes in the early universe, or things slowing down near black holes, or maybe a process just stops entirely.
Right. Clocks can break or run down.
Exactly. So that doesn't work as a truly fundamental bedrock measure. You need something more basic.
Okay, so recurring tasks are out. What's the alternative?
Instead, they introduce a really critical concept, the null task.
The null task.
Yes, and it's defined simply as doing nothing.
We need nothing.
Just nothing changing. What's fascinating, and sort of the core insight here, is that they identify this doing nothing as the shortest possible task. It's the baseline, the ultimate absence of change.
The shortest possible task is no task at all.
In a manner of speaking, yes. Think of it like the universe's ultimate baseline is perfect stillness, zero change.
Okay, I think I follow. So how does that give us time?
Right, here's the breakthrough connection. Emergent time, the time we experience, is derived by comparing changes in systems against sequences of null tasks.
Comparing changes against doing nothing.
Precisely. This comparison, this measure of how much something does change relative to the ultimate doing nothing, is what acts as emergent time. It's almost like the universe is constantly asking, how much has changed since nothing happened?
Wow. Okay, so wait. If time isn't some pre-existing track we just move along, but something that emerges from the universe simply doing nothing, potentially, it fundamentally rewrites our understanding of causality, doesn't it?
Absolutely.
It's not about events happening in time anymore, but time being woven from events, and crucially, even from the absence of events, from that null task baseline.
Right.
That's
Yeah,
a profound shift.
it is. It flips the script on what's fundamental.
Okay, I get it. This theory, by its very nature, is incredibly abstract. It's a significant departure from the physics most of us learned, even conceptually.
It definitely is highly abstract, no question. And it represents a significant break from traditional physics, which, as you know, is very much grounded in equations of motion and initial conditions.
Predicting where things go.
Right. Constructor theory isn't primarily about predicting where a particle will be at a certain time. It's about what transformations, what tasks are possible versus impossible according to fundamental principles.
Hmm.
Now, a key critique, and it's one the proponents acknowledge openly, is that the explanation risks being circular.
Circular how?
Well, the question naturally arises, how can tasks run or happen without time already existing? Don't you need time for a transformation to occur?
Ah, right. The chicken and egg problem. Does the
Right.
task need time, or does the task create time?
Exactly. It's a fair point, and it's something the theory needs to address more deeply, perhaps by showing how the possibility of tasks can exist timelessly for it to gain wider acceptance. But, despite these critiques and its undeniable abstractness, the theory is widely celebrated for its audacity. It truly offers a fresh way to think about fundamental physics, precisely because it starts from completely different first principles. It asks different questions.
The audacity is certainly striking. You have to admire the boldness of tackling something as fundamental as time itself and saying, maybe it's not fundamental at all. But beyond the intellectual boldness, what are the biggest hurdles, you think, for this theory gaining wider acceptance? Especially with that circularity critique you mentioned.
Well, it's precisely that potential circularity, and perhaps more practically right now, the lack of immediate, easily testable predictions that would directly contradict or go significantly beyond current theories like GR and quantum mechanics.
Right, physics likes experiments.
Physics thrives on experimental validation. And while constructor theory provides this potentially powerful new framework and language, it really needs to demonstrate its predictive power, show us something new, something only it can explain to truly integrate with, or perhaps even supersede, the existing models. It needs to make contact with observation in a unique way.
Makes sense. It needs to deliver the goods, experimentally speaking.
Eventually, yes. That's the long game for any new fundamental theory.
So just to quickly recap where we've journeyed today, we've explored this truly radical idea, constructor theory, which suggests time isn't fundamental at all.
Not a basic building block.
Right, but an emergent property of the universe. It arises from these possible transformations or tasks enabled by constructors.
The facilitators.
And the whole thing is grounded incredibly on the null task, the concept of doing nothing, which acts as the ultimate baseline for measuring change.
That's the core idea, yeah. Derived from possibility and stillness.
And look, this isn't just some, dusty corner of theoretical physics relevant only to specialists.
Not at all.
This is really a reevaluation of reality itself, isn't it? It offers a completely new lens, a new way for you listening to view causality, change, and the very fabric of existence. It challenges us to think beyond our sort of ingrained perceptions of how the universe works.
It forces you to question assumptions you didn't even know you had about time.
Exactly. So here's a final thought to maybe ponder. If time isn't that river, we're all just flowing down, but instead it's a measure of changes happening all around us compared against the ultimate quiet of doing nothing. How does that reshape your understanding of existence? What does it really mean if the very fabric of now, this moment, is woven not from a clock ticking, but from the sheer possibility of transformations, and even from the potential for perfect stillness?